Hello everyone, in this video we are just going to build a remote weather station with the help of DHT11 sensor and OLED by interfacing those to ESP8266. Let's get started. In this particular video we are just going to use three different major components. One is DHT11 sensor, another one is OLED display, and for controlling these two we are just going to write the Python scripts or Micropython scripts on thonny ID for ESP8266 or Node MCU development board. So on the screen you can see a program or a script that I have written for interfacing DHT11 sensor. This has been written in the lecture of interfacing DHT11 or 22 sensor to the ESP8266 by developing the relevant Python scripts. And this is the program that we wrote on the lecture of printing bitmap images to SSD1306 OLED display. So we are just going to club these two scripts together for building the remote weather station. So we are just going to fetch the data from DHT11 sensor and we are going to display that onto the OLED display. So this is what we are just going to do. So I'm just going to copy this particular program, create a new file by clicking on Ctrl N or this particular icon in my thonny IDE, pasting it, and I'm going to save this. I'm moving to the respective location where I want the Python scripts to be saved. Here I'm just going to save it as weather station and cross verify whether it is saved as .py format. So as the first step, let us discuss in detail about the schematic diagram that we are going to build for understanding what we want to do and for understanding to which GPIO pin we want to connect OLED as well as DHT11. Let's get started with that. So let us discuss in detail about the schematic diagram that we are going to build for interfacing or for building the remote weather station using OLED and DHT11 using our ESP8266. So as the first step, I am just going to draw two common lines, red for power and black for ground, and I will connect the ground of node MCU to black rail and Vin of ESP8266 to red rail. Since I am just going to power up the OLED display as well as the DHT11 temperature and humidity sensor with the help of node MCU only, I am not going to use any external power source. So I will connect VCC of OLED to Vin of node MCU rail and VCC of DHT11 also to Vin, and ground of OLED I am just grounding it to the common ground of ESP8266, and also ground of DHT11 I am just going to connect it to the common rail. So now that we have just successfully powered the OLED as well as the DHT11 sensor module, now we just want to connect the data lines of OLED display and DHT11 and also clock line of OLED display. So as per the understanding, we are just going to connect the data line of DHT11 to GPIO2 or D4 of node MCU. So here is the D4. I'm just going to connect this to D4, and data line of OLED display I'm just going to connect it to D2 of node MCU or GPIO4 of node MCU. So this will be connected to D2. So D2. And clock line will be connected to D1 of node MCU or GPIO 5 of node MCU. So I am just taking from here, I am going to connect it to D1. So this is the connection that I am going to make in breadboard, and finally I will be connecting this particular node MCU to micro USB cable of PC USB port, and I will be powering up with that power supply from the USB port. That's it. And we will be developing the Python scripts for fetching the data from this DHT11 sensor module, and we will be printing the data onto the OLED display. So that's all about the connections that I am going to make, and Let's build the schematic in the breadboard and also write the relevant Python scripts for developing and building our remote weather station using these components. And as I mentioned right over here, as per the schematic only, it has been mentioned that is D1 external connector, that is GPIO of 5 is connected with SCL. So there is no change for this. And D2 external connector is connected with GPIO of 4, that is with SDA. So there is no change in I2C lines of OLED display. So I am not changing this. This is also not changed. The configuration is done properly. I don't want this particular line, and I will take this fill and I will bring it inside the while of true, and I want this so to be printed after this. I don't want this. I don't want this frame buff either. So right after this fill of 0, this fill of 0 will empty the display, that is clear screen the display. After this, I just want to display the text temperature in the 0, 2 coordinates of the display. And after that, I just want the temperature value to be printed. So here I am just going to print the temp variable data in the coordinates of 100, 2. And this particular text instance cannot print the number format data. So you just want to convert this particular temp variable into string format. And similarly, as you printed the temperature, you just want to print the humidity data also. Humidity, and I want it to be printed at 20, 0, 20 and 100, 20. So the process is very clear. In these lines, we are just fetching the data from temperature sensor, temperature and humidity data. We are waiting here for 2 seconds, and then we are filling the display with the temperature and humidity data. And further, we are storing and printing the value of temperature and humidity onto the Python cell right over here, like this. Before we very well know about these two programs individually, I hope you remember that, because I don't want to waste your time in explaining those steps again and again. If you want clarity, just go back to that lecture and watch that clearly before watching this particular video. Now I'm just going to save the script, and I'm going to run this particular script in my Node MCU. I have built the schematic circuit that I have explained just before in my breadboard, and I have kept, you can see here, I'm just running the script by clicking on this particular icon or F5 in my keyboard. And as soon as I run the script, you can see the temperature and humidity data has been printed in the cell as well as in my OLED display. I'm just trying to increase the temperature of the DH11 by using a soldering ion. The temperature is increasing. You can see 44. And that's it. So we successfully built a remote weather station by printing the temperature and humidity data on the OLED display with the help of DH11 temperature and humidity sensor by writing the relevant Python scripts on thonny IDE using Micropython for ESP8266. I hope you learned something new by building a digital temperature weather station using OLED and DHT11 or using on ESP8266 interfaces to ESP8266 in this particular video. See you in the next video. Thanks for watching.